Have you ever looked at a block of text, one filled with numbers and percentages, and your brain just hits a wall? It feels like you're trying to solve a puzzle, but you don't even have the picture on the box to guide you. Well, today, we're going to pull back the curtain on a simple, super powerful tool that takes all that data chaos and makes it crystal clear. So let's start by looking at the kind of problem I'm talking about. Okay, just look at this. An enterprise has 250 employees, 50% are men. Fine. Then 10% work in administration, where 20% of them are men. Then 60% are in manufacturing, where 54% of those are women. You see what's happening? The information's all there, but your brain has to do all these mental gymnastics, jumping back and forth, calculating percentages of other percentages. It's just messy, right? And trying to answer a simple question feels like a huge chore.
So if you're feeling a little tangled up in all those numbers, that is totally normal. But seriously, don't worry. There is a secret weapon that is designed for exactly this kind of mess. It's this elegant little grid that makes all of these connections instantly obvious.
And here it is. I want you to meet the hero of our story today, the probability table. Now, you might hear it called a two-way table or a contingency table, but whatever the name, the idea is exactly the same. It is the ultimate organizer for messy, overlapping data. So what is this thing, really? Well, at its core, it's just a simple grid. For our problem, for example, we'll put the departments down one side and gender across the top. And what this structure does is it forces every single piece of data into its one proper home. And as you're about to see, it makes all those hidden relationships just pop right out at you. You know, the best way to really get how powerful this is to just build one. So that's what we're going to do. We're going to take that jumble of facts about those 250 employees and pour it step by step into this simple structure. Come on, let's turn this chaos into clarity. All right, first things first. We always start with the easiest, most concrete number we have, the grand total. The problem tells us there are 250 employees in the whole company. So we're going to pop that number right into the bottom right-hand corner. Think of that as our anchor. Everything else is going to build from there. Okay, next up, the problem says 50% of the employees are men. Well, that's simple enough. Half of 250 is 125, so we can put that in the total cell for the men column. And because we only have two gender categories here, a little bit of quick subtraction tells us there have to be 125 women too. Look at that. The table is already starting to fill in the blanks for us. Let's grab the next piece of info. We're told 10% of all employees are in administration. Okay, 10% of our grand total of 250 is 25. So that's the total for the entire administration row. Now, the next part says 20% of those 25 people are men. So 20% of 25 is 5. And if there are 5 men, there must be 20 women. See how every piece of information just slots perfectly into the grid? Let's keep this going. The text also says that 60% of all employees are in manufacturing. So 60% of 250 gives us a total of 150 people in that department. Now here's the key part. Of those 150 people, 54% are women. A quick calculation, 54% of 150 gives us 81 women. And once again, simple subtraction does the rest. 150 total minus 81 women leaves 69 men. And this right here is where the magic really happens. We actually don't need any more information from that original wall of text. The rest of the grid just fills itself in. Seriously. The total for the sales row has to be 75 because all the departments have to add up to 250. And the number of men in sales has to be 51 because that column has to add up to 125. That leaves 24 women in sales. Every row adds up, every column adds up. Boom. Chaos organized. So now for the payoff. We did the heavy lifting of getting everything organized. And with our completed table, answering those tricky-sounding questions becomes almost, laughably easy. This isn't just data anymore. It's insight, just sitting there waiting for us. All right, first question. If you pick one employee at random from the entire company, what's the probability they work in sales? A minute ago, this was a pain. Now, it's a piece of cake. To get the answer, we just have to look at the table. It tells us exactly where to go. We just need the total number of people who work in sales, which is right there, 75, and we're going to divide that by the grand total of all employees, which is 250. And there it is. 75 divided by 250 is 0.3, or 30%. No fuss, no second guessing. The table just hands you the answer.
Let's try a more specific one. What's the probability of randomly picking someone who is both a woman and works in sales? This is all about finding where those two categories overlap.
And again, we just look at our beautiful table. Find the women column, trace it down. Find the sales row, trace it across. And see where they meet. The answer is sitting right there in that single box, 24. That's how many women work in sales. So the probability is just that number, 24, divided by our grand total of 250 employees, which gives us 0.096, or 9.6%. See? The organized data makes finding the answer totally effortless.
Okay, now for the kind of question that really trips people up. This is what we call conditional probability. And notice the key wording here, among the men. That phrase changes everything. We're not looking at all 250 employees anymore. Our entire world has just shrunk.
This is where the table is just fantastic. Because the question specifies among the men, we can literally just ignore everyone else. Our new total, our entire universe for this question is just the 125 men who work at the company. And within that group, the table tells us 69 of them are in manufacturing. The whole game is realizing that our denominator, our total, has changed. So the answer is simply 69 divided by our new total of 125, which comes out to 55.2%. The probability table makes even a tricky idea like conditional probability feel totally intuitive and visual. So you might be thinking, okay, this is cool for a math problem, but what about the real world? Well, the beauty of this tool is that it is absolutely universal. This isn't just for class, it's a whole way of thinking. It's about learning to think inside the box to find some real clarity. You've probably seen data organized in a Venn diagram before, right? And those are a great visual tool. Well, a Venn diagram and a probability table are really just two different ways of looking at the exact same organized information. One uses overlapping circles to show relationships, and the other uses this simple, clean grid. So how can you actually use this? Think about it. You could use this to sort customer feedback by crossing the product type with the star rating, or manage a big project by using task status and which team is assigned. Analyzing survey results, compare age groups and their responses. Basically, anytime you have data with overlapping categories, this table is your best friend. So I'll leave you with this one final thought. Just think about all the information you deal with every single day, maybe at work, maybe in your personal life. What confusing data, what messy collection of facts could you make sense of and understand better right now just by drawing a simple box?